Hey everyone, this is Derek, and this will be the first of two videos about differentiating the natural log function. And natural logs are actually super easy to take the derivative of because it's a formula. The derivative of a natural log is going to be 1 over x every time. And then we're also going to have a chain rule form of this, and that's going to be when the argument is something a little bit more interesting than x, when there's actually a little bit more going on here, where it's a function unto itself. Then we'll have this version. And so here we're going to have the natural log of g of x will be 1 over g of x, the same way this is 1 over x, but then it'll be times the derivative of g of x. So let me show you how that works with some examples. This first one, we have f of x equals ln, this stuff, find f prime. So our inside function, this is going to be this chain rule form, and pretty much they're all the chain rule form. Our inside function, or g of x, is this 3x squared minus 8x. And then we're going to need to know g prime as well. So let's just go ahead and grab that while we're here. So 2 times 3 for 6x, and then minus 8. And then f prime is just going to be 1 over g of x. So that's this, 1 over the argument of the log. And that's just like our 1 over x over here. And then that will be times g prime. And so basically just to write that a little bit better, you can kind of think of this as over 1. So I'm just going to write them over, multiply it out. And that would be it. If something happened to factor out of the numerator and denominator, we would have to reduce, but I don't think they're going to do that. But it'd be something to look for. Okay, so for this one, we have a natural log, and then we have this 3 over x. So I'm going to rewrite that. So 7 ln x. And then this, remember, we can do the trick with the exponents. So if we have a 1 down there, when I bring it up, I can write that as a -1. And now I can just think of this as a simple power rule problem. And so I can take the derivative of each piece. So now my f prime of x, this will be 7, and then times 1 over x, and I'll clean that up in a second. And then -1 times 3, so it'll be -3x to the -2. And then that's not maybe the prettiest form of the answer, so let me just tidy up a tiny bit. So we'll do 7 times 1, and that will make 7 over x. Oops, that should be a minus, sorry about that. And then this -3, the -2, it's not in parentheses, right? So it's only working on the x. So that would bring the x squared down below. Okay, so for this one we have, there's 2 terms, and then this term has a product. So we have this chunk minus that chunk, and then within this first chunk we have multiplication going on there. So for this piece I'm going to use product rule, and then this will just be a little power rule by itself. So let me head over here and go, u is going to be 3x to the 4th. So then u prime is going to be 4 times 3 would make 12x cubed. And then v will be that ln x. And then v prime will be 1 over x. And then remember to do the inside 2 times the outside 2, or sorry, the inside 2 multiplying plus the outside 2 multiplying. So here and here, we would have 12x cubed times ln x. And here we'll have plus 3x to the 4th times 1 over x. And so that is, this is that. And then now we're to the little second term right here. So we're going to go 6 times 2 would be 12. Let me just write that out. So we'll go 12 over 3, and I'll reduce in a second, and take 1 off the exponent and get 5. So now I have kind of all this mess about, so let me clean this up. So that is pretty much what it is. So we're just going to write that, and this is f prime, as 12x cubed times ln x. And then here I can cancel one of those x's, so that'll be plus 3, and then x cubed. And then 12 over 3 would make a 4. And then x to the 5th. Okay, so this question and the next one are really easy to get confused, and it's just this very, very kind of subtle placement of parentheses. So this one is, we could do this a couple of ways. We could do this as a, basically as a chain rule in a log, which would, we could, but it would be really irritating. And if we just remember our properties of logs, we can do this a lot easier. This is that same property that we saw, ln of x to the r equals r ln x. We can bring that exponent down front when we have something inside the log with an exponent. So if I do that, then there's no more composite function. Well, there isn't a composite within a composite. We just have this easy little natural log to work with. So I'm going to rewrite this as f of x equals 4 and then times ln 5x. And now I can just do my my derivative here. So f of x equals 4 times, that would be 1 over 5x times the derivative of 5x, and the derivative of 5x would be 5. And then we have, these are, like, think of them as over 1, and then the 5's cancel. So, oops, and this should be prime. F prime x equals 4 over x. So a much easier problem. Anytime you have a log with an exponent like that, bring that down front and you get a much, much easier version of the problem. You end up at the same spot, just a lot less steps this way. So then this is not the same as this one. And so here, this one is like I have ln of essentially x to a power. This one is like I have ln of x to a power. Okay, my handwriting on that last take went awry, so I'm going to try this again. So this is number 5. So the thing I have in the notes that I was trying to show is that if you have this, it's not the same as that. So this is the difference between problem 4 and problem 5. So this time we have this chunk squared. In this one, we only had the argument raised to the power rather than the log. So what I'm going to do with this is, this we can kind of think of in this shape as a u to the 5th. And so then when I take the derivative of this, it would be like 5u to the 4th times the derivative of u. That would be our chain rule with the power. So what we got to do is figure out, so if u is this ln x minus 1, I think in the notes I've been calling it g of x, I just happen to call it u in this example, then u prime equals 1 over x minus 1. But then you have to be a little bit careful, and this wasn't the best example for me to pick, because now we have to do times the derivative of this inside piece, which in this case is just a 1, and so it doesn't change anything. So u prime is just 1 over x minus 1. But if this had had a 2 right here, then that would have been multiplied by 2, and you'd have this mysterious 2 floating around. So that's the one I wanted to go back and make sure I actually pointed out. So let me now get this all set up using this idea. Okay, so here it is all written out. So here is our 5, comes down front, argument stays the same, take 1 off the exponent, and I have to multiply that by the derivative of the inside. So ln x minus 1, it would be 1 over x minus 1. And then again, I'm just showing this times 1, because if this was any coefficient other than 1, that would be a number. And so it's easy to miss that little step of multiplying this by its derivative. And so now that I have that, I just need to get that cleaned up a little bit. And there's not much to do other than just write it together. So let me rewrite it. And that would be the final form for your answer.